All right, Warriors, good afternoon. Good to see you. I hope you all are doing well. Here's what we're going to do today. Looking at our map check, this little red arrow is where we're at. We're going to talk about regression today. On Thursday, we're going to do a little bit of we drive on regression and published. It is available right now on Canvas is your regression assignment. That'll be turned in on Canvas no later than 11:59 p.m. on Sunday. So that's available now. Again, I never like it when you do that during class. So I'd prefer that you didn't, so that you get the concept and then you can do any problem anywhere. I just want to highlight that regression assignment is on Canvas. It's not on my stat lab for don't look it there or don't look for it there or try to do it there or submit it there. Find it on Canvas assignments and then submit it on Canvas assignments. Pretty straightforward. Looking ahead to next week, we're going to spend all week prepping for the exam. Okay, all practical work all week long. We'll do two Zoom sessions, Tuesday and Thursday. And then not this Friday, but a week from Friday, I'll post your classroom interaction and participation assessments. And also on Friday, I'm just going to update my chart right here. I'm offering reading day repetitions. And again, reading day repetitions are not required. So I know some warriors like on reading day. I've been asked before, hey, will you be available on reading day? And so I've got from 9 to 12 and also from 1 to 3 p.m. that day. You can sign up for a 30-minute block if you want to. I'm not keeping a black book, so you get extra credit if you sign up or if you don't. That's not how that goes. But if you want some last-minute love before you head into the exam one-on-one with me, then you can sign up for that. Just email me and say what time you want. I'd like 9 to 9:30 or whatever, or don't do it. It's up to you. Again, I just offer that out there. And then the final exam will be on Thursday, the 14th. I still haven't, quite honestly, I haven't thought that much about what time and all that. We have a slot. I just haven't looked at it lately. It'll probably be the same format at a minimum as we did last exam. I might give you more time, more to follow on that. Questions on the map check? Okay, everybody ready to go? Here's what we're going to do today. We're going to talk about regression. We are recording. We're going to talk about why we do regression, when we do regression, and how we do regression. Pretty straightforward. Before we get into that, I didn't alter my agenda at the last minute. I want to spend about 5 minutes talking about p-value because I had a couple questions about p-value. I think that stumped at least a couple people. So I'm going to spend about 5 minutes on that before we get into regression. And then depending on how regression goes, we might actually do a Pearson problem and get another rep in on p-value. So potentially we're going to bookend today's discussion on regression with p-value. At a minimum, we'll talk about p-value up front, and we may not get to p-value on the end. Make no mistake, p-value has nothing to do with regression, two different concepts, okay? So don't confuse those two. All right, let's talk about p-value real quick. Let me fire up my handy-dandy pad here. Okay, so the bottom line on p-value, let's put this into two big buckets. All right, so when we're doing a p-value method, one of the ways we could look at this is, are we doing a Z statistic or are we doing a T statistic? Because depending on this, we're going to use some pretty radical different methods to determine p-value. And again, a p-value in plain English is the probability of getting a certain result, okay? And we know with a p-value, if it's lower than the level of significance, we're going to reject the null hypothesis. And if it's not, we're not. So first and foremost, we have to ask ourselves, where are we? And we know that we do Z statistics in one of two conditions. When we're working with population proportions, and when we're working with population means, where we know the standard deviation. Over here, we know that we're under one condition, and that's when we're working with population means, when we don't know that population standard deviation. So let's just start over here for a second, okay? So the first case is that the first thing we need to do in order to find out the p-value is we got to determine the value of the t-stat. Okay, really can't go anywhere without that. So once we have that, we need to determine what tail are we working in. All right, so we have really, I guess we have three options. I guess you could, well, there are three options. One option is that we're working with a two-tailed test. And if that's the case, we're going to use the Excel function t.dist.2t. All right. If we're working with a one tail and we're in, come on, pen, don't fail me now. If we're working in the left tail, then we're going to use this function, t.dist, and it stops there because it defaults to the left tail. And if we're working in the right tail, we're going to use the function t.dist.rt. Now, in all cases, once we figure out the appropriate function, Excel is going to ask us to populate what's inside of these parentheses. So I'm just going to use tdist. I'm going to just pretend we're doing a left-tailed hypothesis test. So we'd have something that looks like this, tdist. And the first thing Excel is going to ask for is this mystery X value. It's going to just write X. Well, we know that X is referring to this t-stat. So we need to put that value in there. I'm just going to write t-stat. And we also know that has to be, we have to make that positive. Even if it's negative, we have to make it positive because Excel won't accept it otherwise. The other thing it's going to ask for is degrees of freedom. All right. We know that degrees of freedom equals n minus 1. So I'm just going to put df in there. Okay, I'm obviously not going to enter df, but that's what I got to put in there. And the last thing I think I forgot when I taught you all, but y'all are figured it out, is it's going to ask cumulative or not, true or false, and we're going to put true in every instance. Okay, and I think some versions of Excel allow you to put 1, but either way, I type true and it doesn't fail me there. Okay, so that's what I'm going to do to determine p-value if I'm over here. Now, if I'm over here, I'm going to go completely different. All right, so the first things first, well, not completely different. I'm going to figure out what my z-stat is. So just like over here, the first thing I did was figure out the t-stat. First thing I'm going to do is figure out that value for z-stat. And from here, I've got one or two ways. I could go to the Z table, or I could use this function, norm.s.dist. And if I use this function, I'm going to put that Z stat. It's going to ask me for Z. And then same thing like over here, it's going to ask me true or false, and I'm going to put true. Okay, either way, this is going to give me some sort of probability, something that'll look like, you know, it'll usually be some kind of 4-digit decimal. Now, here's the kicker. All right. Really, if you are in the right tail, you've got to do a 1 minus. Now, how do you know if you're in the right tail? Okay. So let's just first talk about you're doing a one-tailed test here. Okay. In the situation that you're doing a one-tailed test, how do you know you're in the right tail? When I say right tail, I don't mean right as in terms of correct. I mean this tail over here. Well, if your Z-stat is positive, all right, and you're doing a one-tailed test, you are in the right tail. All right. So if you are in the right tail, the number that you get from either the Z table or this function right here, is probably going to be pretty high. Um, it's not necessarily going to be in the 90s, but it's going to be higher than lower. It could very well be 0.5420, for example. But whatever it is you get, you have to do a 1 minus. Okay, because otherwise you're getting this number in here and you don't want that number. That's if you're in the right tail. And the way that you know you're in the right tail is if that value is positive. Now, here's where it gets trickier. If you're doing a two-tailed test, regardless of this p-value, whether you're in the left tail or not, you have to do a times 2. But if your z-stat is positive, you still have to do a 1 minus on a two-tailed. So whatever this is, 0.4580. I think that's right. Okay, so let's say you get a positive z-score. You convert that into a probability. You do your 1 minus. You get this value here. You're still going to multiply that by 2 if you're doing a two-tailed test. Okay. So regardless, you get this value, you have to do a 1 minus. If you're doing a one tail, you stop there. If you're doing a two-tailed test, you're going to take that value and multiply it by 2. All right. But the first question is, am I doing a one tail or a two-tailed test? If I'm doing a one-tailed test, am I in the right tail? If you get confused of whether you're in the right tail or not, if this value is positive, you are in the right tail, meaning you are right of the mean, which means you have to do a 1 minus. Okay. There may be instances where you got this number here and entered that into Pearson. Pearson's not going to like that number because you haven't done your 1 minus. If you're doing a two-tail, you've got to take that, multiply that by 2, regardless of your z-value period. Okay. Questions on any of this?
Well, I don't have a question, but when I was working through Pearson this weekend for the t-stat, the p-value, it actually, my Excel accepted the negative number and I got the right answer.
Okay.
So I don't know if it's just my version of Excel or what. So
Yeah, Jennifer, I don't know either, but that's good to hear. That's one less thing you got to worry about. On mine, it doesn't like negative numbers here. So,
okay.
but again, t-stat is kind of like z-stat, and then whether it's positive or negative, it's the same distance away. So
Yeah, I mean, it was just kind of through trial and error that I figured that out because I kept putting it in without the negative sign and it kept giving me the wrong answer. Like Pearson wouldn't accept my answer. So I just decided to try it with a negative and it worked out. So
yeah, I don't know. I guess if you can put the actual t-stat in there and it'll give you a value, then super.
okay.
If that won't work, then put the positive value in there, or the absolute value, I guess I would rather phrase it, and then see if that works.
Okay.
All right. Anything else from anybody on all this?
If you're doing a left side, do you still have to multiply that by 2?
If you're
If
doing
we're-
a
Yeah.
two-tailed, yes, you
Okay.
do. Okay. So if you're over here and you're doing a two-tailed test, that's going to give you that value. But to find out the total P, you've got to multiply that by 2. That'll give you this part over here. Okay. Does that answer your question?
Yep.
Okay. Other questions on this stuff right here? All right. There's no substitute for quality reps. So the more reps you can get in, whether it's through Pearson Practice or the Practice Plus Up packages that I've put for you on Canvas. Again, wake up in the middle of the night, go grab a midnight snack, pull out one of those, get in a little secret rep in, or maybe not. Okay. So with that, we will get out of here and we're going to go into regression. So first, I need to tell a little bit of story. A story about the ancient times when people lived in caves, long before Instagram and pandemic and COVID-19, but people lived in caves. And they were very happy in these caves. They didn't really do much outside the cave. And every now and then some youngster would ask, "Hey, mom and dad, why don't we go outside of the caves?" And the answer was always the same. Because outside of the cave is where the evil beast lives. And we know this from the ancient hieroglyphics that are on the wall. Terrible things that might happen, that if we even mess with these hieroglyphics, the beast might be unleashed on society or the way that we live, and the grand apocalypse will happen, destroying everything we know. And so with that, the people stayed in the caves and kind of stayed aloof, not really knowing much about the world, but happy in which they lived. All of the tribes accepted this with the exception of one tribe, which was the D3M tribe. And the D3M tribe said, wait a minute, we're scared of this thing called regression. We got Excel, which is like a pretty little badass machine gun. And beyond that, we got this thing called this beautiful Batman brain that we have. So we're not going to fear the Reaper. We're going to get out of the cave and we're going to face this beast head on, and we're going to rock this thing out like Judas Priest. And what they found was when they got out of the cave and they looked regression in the face, it really wasn't a beast at all. It was a happy little bunny. I mean, what's the worst thing that can happen with a bunny? You pet it, and I guess it bites you. I don't know. I've never tried to pet a bunny. But my point is, at the risk of generalizing, there are a lot of folks in the world that hear the word regression and they get scared and they run to their caves. And I'm telling you that regression really isn't that big of a deal. Now, if we do try to figure out regression using those ancient hieroglyphics, it can become kind of cumbersome. All of you are capable of doing it this way, but we have easier ways of doing this with this friend called Excel. And that's what we're going to do today. We're going to show you how to do regression in Excel. So the first question is, why do we want to do regression in the first place? What actually is regression? Well, regression is when we can spot a trend between two variables. Okay, so that is the first step. And a trend is very easily defined. It's not like bell bottoms coming back in style. That's not what we're talking about with a trend. We're talking about something like this. Let's say we have variable A and we have variable B. Well, one example of a trend is that as we increase variable A, variable B also goes up. An example of this might be as the weather temperature increases, the amount of ice cream sold also goes up. Okay, so in this instance, we could use regression to predict some point out here. Pretty useful. So that's one instance we could use regression. Another instance is where we have we have item variable A and we have variable B. And as variable A increases, variable B decreases. So that would look like this. What's an example of that? Well, as the weather gets hotter and hotter, meaning the temperature increases, the amount of hot drinks sold would maybe go down. Okay. And in that case, we could predict something out here if we wanted to. Now, a kind of combination of this, let's say, let me simplify this and say and use the example I just did and say that instead of this being the same variable, it's a different one. So here I had hot weather. Here I have hot weather. Here I have ice cream. And here I have hot drinks. So one thing I could do is say, let's say that I predict the weather is going to be 90 degrees. Then if I was putting together and trying to decide between having B for sale or C for sale, I could go, this projected value is going to be that, which is pretty high. And this projected value is going to be that, which is pretty low. So I probably want to choose to sell B over C. So that's another way that I could use this. I could compare two products against the same variable. In all instances, it's important, and we'll do this again, so don't worry about it if it's a lot at all at once. Hopefully it's not at all. In both instances, A is what we call my independent variable, meaning A more or less is going to happen. The weather is a great example. Very few things is the weather dependent on. So the weather, Mother Nature, is like, I really don't care about what else happens. I'm going to just happen. Okay. And then everything's are dependent on the weather. In this case, the amount of ice cream, at least we're assuming, which I think is a safe assumption, is that the sales of ice cream are going to be affected by the weather. And in that context, B, ice cream, is a dependent variable. Okay? So independent variable. And other way we call that is X. Okay? And dependent variable, which in this case is B, and then C, and we call that Y. All right, so to recap, when we see a trend going on between two variables, all right, something like either going up or down, and we can measure the nature of that trend. I'll talk about that in a second. When we see that, we could probably use regression to predict some kind of future value. Or we could use regression to predict an in-between value. Okay? But before we start using regression, we do want to identify what variable we think is dependent on the other one. In this case, weather sounds like an independent variable. And then these other things, ice cream and hot drinks, are more dependent variables. So we got to get that straight, because if we don't, our math is going to be messed up down the line. So that's the first step in regression. A second step we want to do, just to make sure that we're not just kind of doing things non-scientifically. And this is where some of you, I've been reading a lot of the Way of the Warrior projects. I'm enjoying them. But I think it's a common tendency to throw out this term correlation. And now, after this class, you can call people out on that and be like, oh, wait a second. What do you really mean? And then you can just kind of mess them up, which is half of what this class is all about. First things first, this tattoo right here. Correlation is not causation. Causation. I think I got too much in there. There we go. Causation. Got to be able to spell it to do it. What does that mean? Well, commonly you will find people confusing these two things. The weather didn't cause the ice cream sales to go up or down. It's just that as one goes up, the other one goes up. Okay? So as one goes up, the other one goes up. That is correlation. It is not that the weather caused it to go up. We don't know that. And we'll probably never know that for sure. Did the weather going up cause the sales of hot drinks to go down? We'll never really know that for sure. However, we can say that as the weather goes up, the hot drinks go down, if we have the data that supports that. So we can measure correlation, and we will. We can't really measure causation, not in the way of certainty that we can. So just be careful about confusing the two. They are not the same thing. We have some ridiculous examples in history of demonstrating this. One that's popular within D3M circles is somewhere along the way, you get some crazy stuff, but somewhere along the way, women's dress sizes went up, kind of like this, and the stock market went up. Well, women's dress sizes didn't cause the stock market to go up, or vice versa. So it's a really silly example to show that just because two items are correlated does not mean one causes the other. Okay? But you will hear people that confuse this, in my opinion, quite often. Just remember that correlation is not causation. All right. So we can measure correlation. That's actually called a value R. And the value of R technically goes between it's equal to or greater than -1, less than or equal to 1. The more it's closer to 1, that's a positive correlation. So this graph right over here on the left is probably closer to an R of 1. Okay. Now, my drawing, I'll never know until we look at the data. Okay. But I'm just giving you an example. This one over here on the right is probably closer to a -1. Now, does it have to be exactly 1? No. You'll get values like 0.97, -0.97, things like that. When you have a value like that, for example, -0.97, that shows a very strong direct correlation. In fact, it's a direct negative correlation. As one goes up, the other one goes down. This would be a very strong positive correlation. Okay. Now, when we have values that are closer to 0 than these ends, we really don't have any correlation at all. So, for example, something like a value, an R value of 0.39. That wouldn't look like either one of these graphs. That'd probably just look like a bunch of squiggly line. And we really can't conclude anything between those two variables. We surely wouldn't want to base a decision on that. We'd probably want to go collect more data, but if we didn't have time to do that, we would just say, hey, there's really no correlation between these two variables. Okay, one more thing I'd like to emphasize before we move off of this slide and start working with some numbers on some examples. We can also have a variable of time. Okay. And when I say time, I don't mean like the speed that it takes me to do something. I mean, A could be a time series. So in other words, A could be Monday, Tuesday, Wednesday, Thursday, Friday. A could be this week, next week, the week after. A could be September, October, November, December, January. Okay. And A, when we phrase it that way, A is going to be the independent variable because time, or at least how we've chosen to measure it in terms of calendar time and things like that, is independent. Okay, so most things are dependent on time as opposed to the other way around. But I will show you how we can do that. So, on that note, we compare two variables. Just remember that one of those variables could be time if we want it to be. It doesn't have to be, but it could be. So, any questions on this so far? Kind of context of where we're going. All right. So with that, let's get into some examples. You can see where my mind is usually, not necessarily where it should be. All right. So we got hot dogs and onion rings. We got, you name it. We got the hockey rink. We've got the cafeteria. Megan's like, I know she's cringing. Ah, that junk food. What are you doing? So we want to know, hey, what is the relationship between these two variables? As we sell one, does the other one go up or does it go down? Now, with this instance, we don't necessarily, I mean, we could assume that hot dogs are dependent on onion rings. We could assume the other way around. We'll just say that we're going to label hot dogs as our independent variable. And I guess that probably makes sense. We think about hot dog as kind of the main thing and onion rings is kind of a side dish. So just we're going to label, and maybe we have information to believe that onion ring sales are dependent on hot dogs. So in that case, hot dogs would be X, onion rings would be Y. Now, just because we're good D3M warriors, although we don't want to mess ourselves up, so it might be good just to sort this data so that it is sequential. So we'd go to a sort and do a custom. I always like doing a custom rather than having Excel do it for me. I want to do smallest to lowest, so that's the A to Z thing, but I want to sort by my independent variable. So I'm going to choose hot dogs just to get that data nice and clean. Of course, be careful if you're not comfortable with doing what I just did. You either need to get comfortable or just leave the data alone. If I wanted to graph it, I could do it. I could insert probably this scatter plot here, something like that. But I do got to know what axis is what. Well, remember, because x-axis is my hot dogs. So hot dogs down here and onion rings like that. So now I can see, remember my example on my other sheet. Wow, this looks like as one goes up, the other one goes up. My first step would be, let's check it out with that R value. So I'm just going to put R right here. And I use this function Correl, C-O-R-R-E-L. And as usual, Excel prompts me to enter some stuff. The beauty about this is that it doesn't matter whether I put my X values in first or my Y values in first. I could do it one way. I could do it the other way. I'm going to get the same correlation value. Okay. So for this, I'm just going to go with putting my X values in first. And then I need that little comma. And then my second array, which is that right there. And envelope, please, 0.983. So that's pretty close to 1. And remember, the closer I am to 1, means a stronger positive correlation. So my graph matches up with that correlation value right there. Okay, cool. Now, I'm just going to grab this, give myself some space for your face. There's already data there. No, there's not. Okay, let's say I have a question like, all right, cool. I've found, at least based on this data, that there's a positive correlation between hot dogs and onion rings. Super. I can walk around Jackson Street and say, hey, did you know that the correlation between hot dogs and onion rings is in 0.98? And maybe, you know, I'll get some new friendships and stuff like that. And maybe not. But practically, let's say that I'm going to sell 700 hot dogs. I believe demand for hot dogs at wherever I'm doing this, the cafeteria, the hockey rink, whatever, is going to be 700. So the question is, how many onion rings should I have on hand? Okay. So what I want to do here is a regression. And this line, there's a line that runs through this. Okay. So I'm going to, there's a number of ways of figuring out the equation for that line. All right. I'm going to show you one way. I think it's a very simple way. For any line, I need a slope and I need an intercept. Now, those values are not going to tell me what this value is, but they're going to get me like to the 5-yard line. Okay. So this is, again, the simplicity of this. I'm just going to enter the equation slope, and it's going to ask me for the known y's first. I cannot stress this enough. This is a common error among warriors to just grab the x's and put them in there first. We always want to put the y's in there first. So that's why we have to have this distinction straight. What is dependent on what? If onion rings are dependent on hot dogs, that makes them my y value, which I have labeled. And I'm going to enter those y's first, that array first. I'm going to do a little comma there, and then I'm going to put my x's in. And that gives me a slope of 0.938. Don't confuse that value with this value. They may look similar, but they're not the same thing. Okay? The slope refers to, for every unit of x that I increase, how much does y increase? And it's almost a 1-for-1. All right? But again, that value is not the same as this value. Two different things. The next thing I'm going to do, and just kind of so that I don't hurt my head, I'm just going to get rid of all these decimals because they're just kind of overwhelming right now. There we go. Now, the other thing I need to determine is the intercept. And as we remember from back in the day, when life was a lot simpler, the intercept refers to where along this y-axis this imaginary line intersects. All right. And all I'm going to do here is enter intercept. And it's the same thing. It's going to ask me for the known y's first. So I'm going to load those in. And then I'm going to load these known x's in. Same. Okay, it's a negative value, which I'm not, that's not a bad or a good thing. It's just a thing. It makes sense. If I drew this line, it would intersect the y-axis below the x-axis, which would make that a negative number. So, but remember, these values alone don't get me into the end zone yet. I have to do one more thing. All right. And I am just going to get my pad up here real quick. Let's see here. Okay. So conceptually, here's what I'm doing. I have an X variable that's hot dogs, and I'm making the equation for this line so I can solve for Y, which is my onion rings. My slope is going to go here, which some people write this. I've seen this written about 4 different times. Some people label the slope as M. Okay. That's that value that's going to go here. And then B is the y-intercept. Sometimes I've seen it another way. You could call this Brianna. It doesn't matter what you call it, you know, as long as you know what you're doing to get this value right here. Okay. This intercept here is going to go right there. So you could do this one of two ways. And of course, once I figure out why, that's going to go, that is the amount of hot dogs that I want to make sure I have on hand to marry up with, or excuse me, that's the amount of onion rings I want to have on hand to marry up with those hot dogs, 700. All right, so already I know my slope is, so the equation for my line in this instance is going to be 0.94 x plus, or I could just put minus, because adding a minus, it's the same thing. So minus 5.29. Okay, that is the equation for my line. That's going on up here. All right. So what I'm going to do now is I'm just going to put 700 in for that X. You could do that on a calculator. I'm going to do it here on Excel. You do it either way. It doesn't matter to me. I'm all about you making your life easy, or making your life easy. Now, because of just what I'm dealing with, I'm going to have to erase my little desk pad to work in Excel. But I don't need to memorize this. I just wanted to show this to you, okay, in terms of what we're doing. All right, so what we're going to do now is I'm going to put this equation in here. All right, and I'm going to go ahead and have it refer to that. So I'm going to walk this equation left to right in here. Here we go. First things first, I'm going to refer to that slope right there. Okay, 0.94. Then I'm going to multiply by X, which is right there. That's my 700. And just because I'm in the habit of adding that slope, I'm going to add that slope. It's a negative. It'll take care of itself. All right. So this means that, just let me get rid of all those decimals. This means that the day that I sell 700 hot dogs, I need to have about 582 onion rings on hand. That's what that means. Okay. So I use regression to find that out. Any questions on what we've done so far? Okay.
Wait, I have a question.
Yes.
So say you have a Y value, but you don't have an X value. Could you do the same thing to find the X value?
Yeah.
Okay.
Yeah. I mean, just reverse the
Yeah,
algebra.
just reverse it. Okay.
Yeah. Absolutely. Seems like I'm forgetting something, but I don't know. Maybe I'll remember it. Hot dogs and onion rings and put it up there. Okay. Let's do one more example. Let's suppose I got something that probably doesn't go together. Hot dogs and spinach salad. I don't know, Megan. Well, maybe. Anyway. All right. So same. And let's say that I've got a decision to make about what I should put next to hot dogs. Now, intuitively, I know that probably onion rings are going to sell more, but let's just get beyond intuition. I mean, after all, that's what D3M is all about. We want to put all those posers aside that are just operating under intuition all the time and hopefully not making $1 million decisions, although some of them are. And we want to come in and drop some science with defiance and be more certain of things by injecting some logic into the situation. Okay? So it doesn't really matter the order that you want to go here. We could start with correlation. So let's do that. And same. Again, it doesn't matter what array we put in first. we'll just go ahead and put this one in first. And oops, too many. See what I did there? I'm throwing that 700 in there when it doesn't have, that 700 is a bachelor, right? Doesn't have a partner yet. So I can't put that one in there. I need to stop there with that 622. And same on this side over here. And drum roll, please. I expect a pretty negative correlation. And check it out, negative 0.94. Again, that's pretty direct negative correlation between these two variables. It's not something kind of wishy-washy like 0.46 or negative 0.6. I mean, that negative 0.94. So just to keep things clean, I'm going to do a custom sort again. Because that hot dogs is going to be on my x-axis, I'm going to sort by the hot dogs. I'm going to go smallest to largest just to get things nice and clean, make sure all my happy marriages stay together. And now I'm going to do, just to kind of make sure I'm bulletproof, check this out. So hot dogs, and I could even say, now, I think scientifically the standard is to lead with the x-axis. It always makes sense to me because that's the independent variable. That's a player that's like, I don't care what happens. You got to base your stuff off of me. So the player is going to go first, hot dogs versus spinach salad. I think that's how that goes, but I don't know. This is all icing on the cake anyway. I got to be able to spell it to do it. Spinach salad. I always have a joke with my boys that we're going to have spinach salad for dinner. Inevitably, I get the same reaction, which you can imagine what that is. All right. So once again, there's this imaginary line running through this that's going down here. That backs up with this correlation right there. Okay. So same process. Slope, intercept. Just to keep things nice and neat and details that really don't matter. Okay, but again, slope. I've got to load those Y's in first and then load those X's in. And I got to be careful that I'm loading happy marriages. I don't want to do anything with that 700 because that's a bachelor versus these other 6 happy married couples that I have. And again, that gives me a negative slope. That negative 0.91 is not the same as the correlation value. They're two different things. This means that for every hot dog that I increase, the amount of spinach salads goes down almost by 1. Okay. And then I need that intercept. I should expect that intercept to be pretty high up on that y-axis. If I trace this line back and back, that should be up there off the scale, probably 900, maybe 1,000. I don't know. Let's see. I'm just going to guess that it's like 1,000 and see how close we are. Again, I always load in my Y's first. That's that mental muscle memory thing you want to get into. Y's loaded in first, and then my X's. Boom. And the envelope, please. 673. So it wasn't 1,000. I was actually a lot shy of that, but it was higher than 700. Okay, I'm on the 10-yard line. And again, so my equation for my line is Y equals negative 0.91 times X plus the intercept of 763.96. So if I have 900 or 700 hot dogs I'm going to have on hand, the amount of spinach salads I should expect to sell that day, I expect that number to be pretty low. Let's see if it is. So I'm going to lead with that slope. I'm going to times by my X value, which is 700, and I'm going to add my intercept, 125. So sure enough, that point is probably right about there where my cursor is. So if I could only stock one item at my concession stands, again, intuitively, you probably said, you would have said, no, duh, why would I ever dream of selling spinach salads along hot dogs? Well, it's an extreme example, so you get it. But I could compare these numbers and get beyond intuition and say, hey, look, my projected demand based on this relationship and this correlation is 125 for spinach salads versus 581 onion rings. And let's just assume for simplicity that some onion rings cost the same as spinach salad. I would probably be better off selling onion rings alongside hot dogs than I would spinach salad. Okay. So that's another tool of regression that we can do, is we can make a product selection. Okay. We can project that demand and then compare two variables, in this case, their products. And then the last thing with this could be something like, let's see, let's just set up a new one. This one, I don't know why I didn't have this ready. I will not make excuses. So let's just do something like this. And this. Okay. And let's say that we have something like this. Okay. And what we want to do is get Excel to work. And we also want to, let's grab these down here. Excuse me. So we want to, we've been looking at hot dogs. Let's say we work at the ballpark and we see this relationship between time and hot dogs. And so from this, we want to think about what kind of relationship do we have, number one, and if we have a trend, an upward trend, and we are looking ahead to, let's say, a big celebration in July. And we want to project and do some forecasting. Maybe if we put in our forecast now with our supplier of hot dogs, we could get a discount or something like that. So there's some reason we want to forecast for July. So that right there is our target. Well, the first thing we want to do is convert these into numbers. So in this instance, hot dogs becomes a dependent variable. All right. So it's no longer the X, it actually is the Y, because time keeps on slipping into the future. And time is the independent variable. Okay. So that's the first distinction. Again, it's the same distinction, same pattern. What's dependent, what's not. Time waits for no man. Time is not dependent on anything in this instance. So that's the first thing we want to do. The second thing we want to do is, I'm just going to do this for simplicity. Excel's not going to work. So if we start, okay, what's the correlation between these two? Excel's not going to like us if we highlight this array of calendar months. It's not going to like that. And, on most days, we don't want to upset Excel. So we're going to turn these into numbers. And it's very simple the way we do it. So if you see something like this, don't get thrown off. We'll just call this time. Okay. We just want to go, okay, whatever our first time period is number one. Okay. It's that simple. And that would make this time period 2, 3, 4, 5, 6, 7. We're not going to mess with July just yet. All right. And so we could even get rid of these months. I'm gonna leave them in just for this example so you can see it happening. I could see where it's more convenient just to get rid of that, but I'm gonna leave it there for now. Okay. So again, when I go down here to do correlation, nothing changes. Well, before I do that, I'm just gonna gray these out. I'm gonna keep them there, but I'm gonna gray them out. And the reason I'm gonna do that is so I can focus on the marriage between the time period numerically and the number of hot dogs. So I'm not gonna use anything in the gray. Okay, back to my correlation. Okay, it doesn't matter which array I pick. I can pick those time periods first. And then my hot dogs next. 0.993, very strong positive correlation. Okay. Now, probably someone out there is critically thinking, probably more than just someone, all of you, and you're going, well, wait a minute. What if, I mean, after a while, this isn't going to just keep going up? You're right. And that is, we got to be careful about how far into the future we're going. So, for example, if we projected all the way to October, it might not be a safe assumption that this stuff keeps going up into October. At some point, hot dogs are going to go back down because ball games aren't being played. The weather's, I don't know, those kind of things. But for now, with this data, we have a pretty strong correlation. And we're not going too far into the future. We're only going a couple months. Okay, we determine slope the same way we always have. Again, the big thing here is that we put those Y's in first. And by now, I probably sound like a broken record, but that's okay. I'm not touching the gray. If I put those months in there, Excel's going to get all mad at me. I'm going to put in those time periods. And I'm going to do the same thing down here for intercept, just like I have now. Okay. Boom. Now, why are you telling me NA? I did something wrong. Known Y's. Okay. Fat finger, as we say in a former life. So again, there's the backbone of my equation. All right. Attention to detail, as we also used to say in a former life. Here's where you got to make sure you know what you're doing. This time period here, Matt, what is that value going to be?
It's gonna be 9.
So May would be 8, June would be 9, July would be 10. Close.
Yeah.
You know, right idea. But Matt didn't just go for 8. Okay, so he was thinking in the right direction. And if you don't trust yourself, you could just say, all right, I'm going to move this thing down as far as I need to and put May and June in there. And move this thing back up. Okay, everybody see that? But common warrior mistake and the beautiful thing about regression is that you can skip a couple months. Maybe like I said, I'm more interested in July, which is a couple months in the future, because I can, if I order now with my supplier, they'll cut me a deal. And maybe I'm less concerned about May because maybe I already ordered for May, that kind of thing. So I've just got to make sure I got the right time period in there and I don't get tricked up. A common error is to just use the next time period. And that's not the appropriate time period. From then, everything follows the same process. So I grab my slope first. I times that by my X, which is that time period that I'm forecasting for. And I want to add my intercept there on the end. This is going to be a lot of hot dogs. 961. Folks ask me all the time, should I round down, round up? Personally, I don't get too hung up on that. If you want to round in either direction, I would round up, because there's that person that you gave 0.7 of a hot dog to, and we all know how that goes. I can just see Tim now. Here, Tim, here's your 0.78 of a hot dog. Tim would probably throw that back at me. All right. He'd be like, where's the rest of my hot dog, bro? All right. So that's an example where I had time as a variable, and all I've really got to do is put that time period into a number. Now, if I wanted to graph this, again, there's probably higher speed ways than this. What I could do is just do this and do this. If I wanted to graph it, or the other thing about, I could do it this way, or I could just grab these numbers right here, because if I'm just doing 1, 2, 3, 4, 5, 6, 7, I don't even need those. I can go solo without them. I don't want to do that because that implies it's a continuous variable. So sorry about that. Let me back up and do this. Boom. So either way, I don't have to put them out here like this. I can just grab these numbers. And if I want to stay consistent, I could say time versus hot dogs, or I could say hot dogs by month kind of thing. All right. So as the season goes on, and of course, if I was going to show this to somebody, I think I'd just go ahead and use this, quite frankly. I'm always about teaching beyond the class. I wouldn't go into a decision maker. So let's say I was concession supply chain guy at the ballpark, and I've got to take this into, and I'm part of a larger briefing to the executive who is making all sorts of decisions, and I'm asking him for money so I can buy 961 hot dogs. I wouldn't show him this way. I would want calendar months out here, because if I show him these numbers, he's probably just going to get mad at me and be like, what am I looking at? Okay. And like I told an earlier section of Warriors today in another class, anytime you visualize something for someone else, you want it to be like a cartoon or a meme or something that people just instantly get. Okay. So let's see if I can do that since we're on the topic. I think I can. Let's give it a shot. Nah, it doesn't want to do it. But if I play around with this long enough, I can. But I want October, November, etc. down here in the real world. For this class, I don't know if I'm hung up on that. I really am more hung up on you getting this value right there and not making this mistake of just using 8 as the time period. But when you're briefing somebody, you want them to get it. Oh, I see that the number of hot dogs by month is going up and probably will into the summer. So, of course, Greg, here's that $5,000 you need to get those hot dogs. Thank you. Next kind of thing. You don't ever want to put more work on the decision maker. That just doesn't go very well. Okay. Questions on any of this?
So you mentioned like earlier how like when you start in October, eventually it'll come back to October and the numbers will go down again.
Yeah.
Do we not have to like worry about those numbers going down? It's just like strictly calculating the data that's shown.
Yeah. So the short answer is no. But the longer answer, so if I give you a problem, it's going to be, and I will either give you guidance or ask you the assumption you would need to make. So in this example here, the assumption you would need to make is that the numbers will continue to increase through the summer. All right. Tim brings up some really good points. With any kind of model that we have, and regression is no different, we have to make assumptions, just like you all did with your Way of the Warrior project. That's why that's a good habit to get into. What is the limitations? What are the assumptions I have to make? if there's no hard and fast rule with regression, some people don't even like doing this. They tell you not even to forecast outside of that. So maybe if I wanted to forecast, actually a better example is here, they would tell you you shouldn't forecast beyond 622. You know, so like you should forecast for a number like 410 or 260 or two, you know, you should forecast in between those two. Well, I don't think you're pushing the limits of the data to forecast to 700. I don't think you're pushing the limits of the data to forecast a few time periods out. But we got to realize the limitations and the vulnerability of our assumptions the farther we go in the future. And with forecasting in particular, the farther we go into the future, the more precarious our forecast gets. Weather is a great example. Weather forecasts are usually done in the next 2 to 5 days, but beyond 10 days, you normally don't see weather forecasts because they're so unpredictable. So for the purpose of the exam, I would give you a problem where it's a reasonable assumption that the trend will continue. And I might ask you, if I asked you for this example, if I asked you to forecast into October with this data, would you, you know, something like, would you feel comfortable doing that? Would that be a prudent thing to do? That kind of thing. And I think the short answer would be no, because number one, it's too far into the future. And number two, the likelihood of a seasonal trend bringing those numbers back down would invalidate the assumption that these numbers will continue to go up. Does that make sense?
Yeah,
Let's take
I got
let's take an even more extreme example. Let's say these were fireworks and not hot dogs. So probably those numbers will go down after the 4th of July. You see what I mean? So if I said, hey, forecast for August, I don't really know if I want to do that, you know, because there's probably some other different pattern. Does that make sense?
yeah, I got you. Thank you.
Okay. So great, always great questions. What else? Any other questions on regression?
Yeah, I have one. So that R value that we find, is that the same thing as that R square value you'd get if you put on the R squared value for that chart with a linear regression?
So it's not the same. I don't teach R squared because I really try to separate what, how do I phrase this? I think if you say the correlation coefficient R, people understand that.
Okay.
Generally on the street, people get that. When you say R squared, it's kind of like talking about variance and standard deviation. Standard deviation, it means something. If I say there's a standard deviation, if I say that Eric is 3 standard deviations away from the mean, I think everybody gets that. If I say the variance of a distribution is something, I can't really do anything with that. So the short answer is that R value is not the same thing. R squared is R squared, R is R, but in more practical terms, R conveys the nature of a relationship. Does that
Okay.
make sense?
Yeah. Thank you.
Of course. I have a question from the great beyond. Telepathically, someone is communicating with me to show where the regression assignment is on Canvas. I just can feel it somehow. So let's look at and see if it's there. Maybe I didn't activate it. So I apologize if I haven't. I got some lag going on. Here we are in Canvas. So it's it's published on my end, available from April 27th. Today is the 28th, so it's there on my view. This is what it's called, final D3M homework. Did that answer? Can you find it now? Let me test this out from, let's see, student view. Nope, I hit it too hard. Let me test my student view to see if you can see it. Okay, so assignments. So I'm seeing it on the student view, available until 3 May, which is Sunday. Okay, so that's where it is. I guess I should change it so it's upcoming assignments, because I didn't say it was due. So I can do that to make it easier for you. But that's the name, final D3M homework. Let's just crack it open while we're here. So you have a worksheet that you got to put your answers on, and you have a Word document that has the scenario and the data and stuff like that. Pretty straightforward. Because it's a speed grader kind of thing, I would just prefer that you put your answers on the worksheet. All right. Pretty straightforward. But as always, if you have questions on it, let me know. Okay, so before I ask for final questions for today, I will tell you something else I will post as a bonus item. So what I did, and we didn't have time to do it, and that's okay. I took one of the problems from Pearson. This is the sterile version. I won't post that. I will post my version with the answers of how to do it. And the reason I chose this problem is because it did p-value under 2 conditions. It did a p-value connected with a t-stat because it was a population mean. And then it did its p-value with a z-stat, which is a population proportion. So I will post that today on today's Canvas, and over here on the right side of the slide, instead of it being blank, you will get a little bit of the process so you can look that over. And if you still got questions, of course, please get hold of me and we can work through that. Okay. Any questions on anything big or small, anything we've talked about, anything we haven't? Do this before I forget. Okay, so Thursday, what we'll do is we'll work through a few scenarios on regression as a group, kind of a we drive kind of thing. You've got your regression stuff to work on. And if I don't talk to you, I'll stick around as always to clear the call if you have further questions you want to talk about. And if I don't talk to you, have a great week, and we will see you on Thursday.
Thank you.
Thank you.